Okay, so now in this part, we're going to talk about the three states of matter. Okay, so when you talk about the states of matter, a state is just, in simple terms, it's just like a form. Yeah, so you have three main states of matter, yes, which are solid, liquid, and gas. Okay, so now we are going to look at these three in diagram form, arrangement, movement of particles in these three states, as well as the forces that holds particles in these three states. Okay, so this one will guide us, as I said, to talk about these three states: the diagram of the particles, the arrangement, the movement, and the forces. Arrangement of particles, of course, movement of particles, and the forces. Okay, so now here we say the diagram. Simple terms, we just put particles that are very tightly closed together. Yes, that is for a solid. For a liquid, we can just put something like that. Okay, then for the gas, as far away as possible from each other. Yes, so now talk about it's like on the arrangement you're asked to describe what we see by the arrangement of the particles. Of course, these are very closely packed. These are loosely packed. Then these are like spread. The distance just between them just to is very big. We just say they are spread widely. My sincere apologies for this. My space was a bit small. Okay, so I'd advise you to get it from my voice clearly as well. Okay, now the movement for these in solid, they only vibrate in their fixed position. Then for the liquid, of course, they vibrate, but there's also that room for movement over a short distance. Then the distance is, the speed is just so high because they are spread far away from each other, such that this one would move going that direction, this one in that direction, this one in the other direction. So they rarely bump into each other because the space that they have is very big. Then the forces that hold these particles is very high. This one we can say medium, this one we can say low. Simple as that. Okay, so now when you talk about for example, when you talk about density, we say density is mass over volume. So now if you'd want to describe this in terms of the states of matter, in terms of the particles, here is something that you need to take into consideration. When we say a solid has high density, what do we mean? We say solid has high density, liquid slightly high, this one low. What do we mean? When density is high, meaning the volume is what? Low. When density is low, meaning volume is what? High. Okay. Oh yeah. So when density is low, volume is high. What do we mean by this? We say that a solid has high density. From this formula, what are we able to derive? What are we able to understand? Okay. When we say the density of a solid is high, it simply interprets to say the volume is low. What do we mean by the volume of a solid being low? We talk about the volume between the particles. If you go to mathematics mensuration, area is the component of volume. For example, you talk about the area of the area of a cylinder. Area of a cylinder, you just say 2 pi r squared, and which is something like that. Sorry, not 2 pi r. You just say pi r squared. That is the area of a cylinder. Now when it comes to volume, you'd say volume is equals to pi r squared times h. Okay, so it's like area is the component of volume. So if the spaces between these particles is small, meaning the density is going to be high, the space between these particles is representing the volume. The area between these particles, the space given, is low, meaning the density is going to be high. So when you talk about density being high, volume being low, the volume is being referred to as the spaces between the particles of that state of matter. Look at this, the gas. The gas, the space that you have there is what? High, meaning the density is going to be what? Low. Yeah. So that's all in this video. Yeah, if there be any queries, please bring them forth. Yeah, and please share the link, invite your friends to join the group. Let us help each other in any way possible. Sure. Have a good night.